Hello, bright minds of the digital world. It's your friend and coding companion, the Web3 Idiot, back with another episode where we decode the mysteries of algorithms together. Today, we're unlocking a new level on our quest. Welcome to the world of Insertion Sort. All right, think back to when you were a kid playing with those fun slide puzzles, maneuvering pieces one slot at a time until the picture made sense. Well, buckle up, because Insertion Sort is the algorithmic version of those puzzles. Now, if you've ever found yourself reordering a deck of cards, you've already had a taste of the insertion sort without even realizing it. It's all about taking one piece, or in this case a card, finding its rightful place and sliding it right in. Simple? Absolutely. And immensely satisfying. Feeling like algorithms are a steep mountain? Don't worry, you're not alone, and that's exactly what we're here for. Today, we take this step together, turning complex into I got this, with a real-world approach. So, are you ready to slide those elements into place and watch a random jumble turn into a masterpiece of order? I promise, by the end of this video, the insertion sort will be another cool trick up your coding sleeve. Prepare for those aha moments as we navigate the waters of the insertion sort. Trust me, it's more like a fun game of Tetris than a tricky math problem. Let's jump right in. So first up, we have insertion sort. This is a similar algorithm to bubble sort and selection sort. The idea is we are given an unsorted array and we return a sorted array. Now, because all of our previous examples have been pretty easy, we've had 7, 6, 5, 4, 3, 2, 1. We're going to mix it up a bit. We'll go 7, 4, 6, 3, 1, 2, and we're missing one number, 5. And our expected output will be 1, 2, 3, 4, 5, 6, and 7. All right. So we have bubble sort that is passing the largest numbers up to the right. We have selection sort, which is inserting the smallest number into the current index. And now we have insertion sort. Insertion sort is pretty much just passing down the lowest digit. So for example, we'll go here. What we need to do is we need to keep track of our current value, and that current value we don't know yet. So we're going to put it as null, and what we're going to do is we will take this and put it right here. So what we want to do is we want to look at each index and compare it to the numbers to the left. All right, so what we're going to do is we're going to first start here. Now 7, there's nothing to the left, so we won't start there actually. But for our example, we'll look here. 7, there's nothing to the left, so we'll keep 7 there. Next, we'll move over here. This will be our current value. So we put our C there and we change it to 4 up here. And then also we'll come down here. We will have pretty much, this is going to be J. J will be our comparison. J will always be equal to this number minus 1. So what we're going to do is we look at this 4, we put it up here as current value, and then we say, oh, this 4 compared to this 7, it is less than the 7. So we'll move over here, and we put 7 at J plus 1, which is here. Next, we move over. J is less than 0, so we break out, and we put our 4 where we currently are pointed, which is J plus 1, which is here. All right, next, we'll move up. Move up. So our current value is 6. We want to compare this 6 to where we currently are, which is I minus 1. So this is J here. So we say 6 and 7. Okay, So 6 is less than 7, so we put our 7 here. We don't change this 7 here. Next, we move down. We have j, and technically we call this one j plus 1. Put that here. All right, and we take a look. We compare j plus 1 and j. 6 is greater than 4, so we insert our 6 here. And since we did that, we move on. Okay. All right, next up we have our 3 is our current value. We compare our j plus 1 to j, which means that this 7 will move up to where the 3 is. Good. And we'll move down. Let's see, next up we compare this 3 to this 6. All right, so we move our 6 up to j plus 1. Next we move down. We compare this 3 to this 4. We move 4 up here. And then j will be a negative number, so we put our 3 in here. Next we'll move up again. Our current value is 1. And we compare our current value to j. So we slide j up into the j plus 1. We move down. Next up, we compare 1 to j, which is 6, so we slide 6 up. Boom, boom, boom. Next, we compare 1 to 4. We do the same thing. We insert 4 where j plus 1 is. We move down. Compare this 1 to this 3 at j. J slides up to j plus 1, and then we break out because j is less than 0. Next, we move on to our next value. So our current value will be 2. Here, we compare the 2 to the 7. So 7 is greater, so we move it up to j plus 1. Next up, we compare this 2 to this 6. This 6 is greater than 2, so we insert our 6 here. We move down again. We compare this 2 to this 4. Same thing. 4 here. Move down. Same thing. This 2 is less than this 3, so this 3 slides up. And then here we have this 2 to this 1. It is greater than the 1, so we slide it. We take this 2 and insert it where j plus 1 is. And then we have our last iteration. We're going to slide up. So our current value is 5. 5. This 5 compared to 7. Okay, we insert 7 at j plus 1. We move down. We have this 5 compared to this 6. All right, it is greater than 5. We insert our 6 here, and we move down again. We compare our 5 to this 4. It is greater than the 4, so we insert our 5 at j plus 1. And there we go. We have a sorted array, 1, 2, 3, 4, 5, 6, and 7. So the pros of this is just like bubble sort and selection sort, it is easy. The cons, it takes a long time. Now, if you watch some of our last videos, you understand what the time complexity is, but we'll get to there in a second. So let's talk about how we write this code, the pseudocode. First up, we need to initialize a function. And just to be straightforward, we're going to call it Insertion Sort. All right, and we will pass it an unsorted array. All right, good. So let's take a look at what we did. So our first thing is that we went to every single one of these elements, which means, as we've done before, that we need to use a for loop, or we could just say loop through all elements of the array, of the unsorted array, okay? And for each one of these elements, we will say create variable to keep current value. Oh, to keep current value. That's not what to keep current value. All right. And then after we do that, we also want to compare create value j to compare to j plus 1, where j plus 1 is equal to I at the start, which means that j is equal to I minus 1. So our I will be up here. This I up here. All right. So there are going to be two things we want to check for. Our first one is if j is out of bounds, which means it is less than 0. Then we would stop. And our other thing is if array of j is less than current value, then stop. And then after we loop through there, we say that array of j plus 1, which would be our new I, is equal to the current value. So that is where we slide in or insert this value here. So remember before we had 6 and 5. We'll slide it down a little bit. So we're going to go through this code real quick with this. So we'll loop through. Okay. We have a value. So over here, 25. Current value is 5. Good. J over here is equal to I minus 1. So we're already here. So this is j plus 1. Basically the same thing here. We do that and then we will stop. So here we will switch. Oh, we didn't say that. Okay. That is why we had to go through a code. Swap values at, or no. We want to say insert. We want to use this word as much as possible. Insert value array at j into j plus 1. So we want to insert it up. So here we go. We have the 6. We put it here. Boom. And then here we have our break case, which is this one here, which means we break out. And then here we say our j plus 1, which is now here, is equal to current value, which is this 5. So we put it there. I think it's pretty straightforward. Our time complexity, similar to bubble sort and selection sort. This will be, we have to go through in elements n times. So this is a n squared time complexity because we have 2 loops pretty much. We loop through this and we compare it to everything to the left. So we have n times n. And then over here we have our space complexity, similar to bubble sort and selection sort. We do not create a new array. So the space complexity is just 1. I think that's pretty straightforward. We're going to go straight into coding just to get it done. All right. So we're going to go line by line. We're going to look here first up, 22. Function insertion sort. And inside we'll pass an unsorted array. Very straightforward. Good. Next we have loop through all elements of the sorted array. Okay. So what we're going to do is we'll say for, it's a for loop because we're going through all the elements. For let I equal. Now, here's what we're going to do. Where do we start? Do we start at 0? No, we don't, because like we talked about before, this 7 has nothing to compare to the left. So we're going to go ahead and move on to the second element at position 1. So here we'll say I equals 1. I is less than unsorted array, and we want to take the length of it. We don't want to go out of bounds on the right hand side, and we'll increment or increase I by 1 each time because we will go from 7 to 4 to 6, so on and so on. All right, next, let's see. We want to do line 25, create variable to keep current value. So here we go. let current value equal unsorted array at I. Very easy. And then we also want to create the value j to compare to j plus 1. So we'll say let j equal I minus 1, because that is what we figured out, j plus 1. So j plus 1 is equal to I, which means that j is equal to I minus 1. So that is how we get this j here. All right, and then next we have if and if. So we have two things that we need to keep in mind when we're going through this. So for that, we need to use a while loop. So while two things are happening, while two things are true. So our first one is while j is greater than or equal to 0. All right. And we also want to look at this one here, 28. Array, unsorted array at j is greater than current value. All right, if this is true, right, like we said up here, we want to insert our left value to j plus 1. So here we'll say unsorted array at j plus 1 is equal to unsorted array at j. We'll make it look good, some good spacing, and that should work. Good. And after we find the correct j to insert our current value, that is what we'll do. We will say unsorted array at j plus 1. Boom, boom. Because we always want to keep using this. This is where we are inserting the new values. It's equal to the current value. All right. And then finally, we want to return unsorted array. But I guess at this time, it would technically just be a sorted array, but who knows? All right, let's go ahead and make some test cases. Let test array equal, and let's go ahead and steal this one up here, 7, 4, 6, etc. We'll put it here, 7, 4, 6, 3, 1, 2, 5. All right, and we will console.log, and we'll say insertion sort, and we'll pass in the test array. So over here, we're expecting to get 1, 2, 3, 4, 5, 6, 7. Let's run it. And something is going wrong. But what is it? Let's see. Well, J. Okay, something is not going well. Okay, let's try it again. Is something wrong? Let's see. Let's pause. What is going wrong here? Is it my bad spacing? Could that be it? So we have current value is equal to unsorted array at I. Good. So we say while j is greater than 0 and unsorted array at j is greater than current value. Okay. Oh, that is what we forgot to do because we didn't write it down. We need to decrement j. J minus minus. We forgot to move j to the left. All right, this should work now. Let's run it. And there we go. 1, 2, 3, 4, 5, 6, 7. So we were stuck in a loop because j was not increasing or decreasing, and it did not break these cases here because we didn't change j at all. So we were just comparing this number to this number an infinite number of times. So that is a good way to debug. And that is also why it's good to talk yourself through your code. All right, let's go with, throw in some crazy numbers, 100, 1,000, and minus 1. So we should get minus negative 1, 1, 2, 3, 4, 5, 6, 7, 100, 1,000. Let's try it again. And that is what we get. You can't really see it. I'm sorry, but that is what we get. All right. So that is selection sort. No, it's not selection sort. That is insertion sort. Yeah. If you have any questions, post them in the comments. I'll try to get to you right away. And I hope you took something away from me going over this insertion sort. Thank you. Have a great day.